So what we've got here is a table of values that you've already been given or that you've been able to work out from a word problem. And the garden beds is kind of an example of working out the table of values from the word problem. Not that everyone was doing a table of values, which I thought was a bit silly. But anyway, so you've been given a table of values and you've been asked to work out the function and maybe graph it as well. I won't do a graphing exercise because I just did one just a second ago. So we have a table of values already given to us. There are two things we need to isolate to work out the function. First of all, we need to work out, I'll give you the official fancy schmancy term for it. We need to work out the common difference. And that means for every one step in x, see, this steps up by 1, yeah? So if I add, sorry, that should have been -1 there. For every, there is a unit 1 shift for every value of x here. If there isn't a shift of 1, just be careful. But there is here. It goes from -2, shifts 1 unit up to -1, then another unit up to 0, then another unit to 1, then another unit to 2. Make sure that it is a shift of 1. If it's not, then we need to be careful of that. What we then need to do, to determine that it's a linear graph, a linear function, we need to make sure that for every shift of 1 of x, we have the same shift for y. If we don't, then it's not a linear function. But here, I hope you can see that we do. To go from 5 to 3, I have to take away 2. To go from 3 to 1, I have to take away 2. To go from 1 to -1, I have to take away 2. And to go from -1 to -3, I have to take away 2. This is called a common difference. In other words, the difference between two of the y values there that are next to each other is the same. That's another meaning for the word common. Common means the same. So it's the same difference all the way along. Again, just to point out again, for every single shift of 1 unit of x, the shift in y is exactly the same. If I shifted from 0 to 2, then the shift wouldn't be -2, it would be -4. So I'm just talking about a single unit. Jess?
When you write what the function is, do you write y equals -2x plus 1?
Yep.
Okay.
Yep. You're just confirming you know what to do?
Yeah.
Yep. So that shift becomes the coefficient of x in the linear function. So we've got y equals -2x. We haven't finished the function yet, but that's where what happens to that -2. The reason why, and hopefully this is the last time I need to explain this, the reason why is because basically what we're doing is we're collecting -2's up. So it's a bit tricky to talk about negatives, so let me just go from 0. From 0 to 1, I've collected 1 -2. From 1 to 2, I've collected 2 -2's. From 2 to 3, I would have collected 3 -2's. So if you could imagine, if I'd got x equals 10, by the time I get to x equals 10, I will have collected 10 -2's. So basically, there's the -2 times the number of x. So if you think about it in terms of whole numbers, if x was 10, I'd have 10 lots of -2. So that's why that number there appears as the coefficient of x, -2x. The next thing we have to do is we have to look at what's happening when x equals 0. When x equals 0, y equals 1. When x equals 0, y equals 1, according to the table. So when x equals 0 here, y has to equal 1 as well. But it doesn't at the moment. If I substitute x equal to 0 here, x becomes 0. 0 times -2 is 0. So we have y equals 0. But up here, we're told that y has to equal 1 when x equals 0. So I need to take whatever value y is at x equals 0 and tack it on to the end. If this was a negative number, I'd subtract it. It's a positive number, so I add it. So it becomes y equals -2x plus 1. And if you want to be a little bit fancy, and you won't gain any marks for doing this, except my undying admiration, you could write that as 1 minus 2x. You don't have to though. Okay, full marks for writing -2x plus 1. Okay, so again, just to repeat, The number before x, the coefficient of x, is the step, and we add or subtract whatever value is the y value when x equals 0. And that's basically how we go about working out what a function is based upon a table of values. Any questions?